Hello there, and welcome to Cosmic Slumber. Tonight we are drifting outward, past Mars, past the asteroid belt, into the cold golden light of Saturn. It is a planet built almost entirely from gas, light enough that it could float on water if there were an ocean large enough to hold it. It wears a halo of ice and rock so wide it could stretch nearly the distance between Earth and the Moon, and so thin in places that starlight passes almost straight through it. It has moons that hide oceans beneath their frozen crusts, moons that rain liquid methane, and a storm at its pole shaped like a perfect six-sided hexagon that has churned quietly for decades. The more closely we look at Saturn, the less it feels like a distant, frozen curiosity, and the more it feels like a slow, patient world entirely its own. If you enjoy these gentle journeys, I invite you to like, subscribe, or leave a thought below. It helps other sleepy minds find their way here, too, one quiet orbit at a time. But for now, all you need to do is relax. Let your shoulders soften. Let your eyes grow heavy. Let your thoughts drift outward, past the warmth of the sun, into the cold gold light where Saturn turns slowly in the dark. Let's begin. Saturn is so light for its size that it would float in water, if a bathtub large enough existed. Saturn is made almost entirely of hydrogen and helium, gases far less dense than the rock and metal that make up Earth. Its overall density is actually lower than that of water, meaning that if you somehow found an ocean vast enough to hold it, Saturn would bob gently on the surface rather than sink, an oddly playful image for a planet more than 9 times the width of our own. Saturn takes nearly 30 Earth years to complete a single orbit around the Sun. Because it sits so much farther from the Sun than Earth does, Saturn's year stretches out enormously by our standards. A person born today would need to wait roughly 3 decades simply to witness Saturn complete one full journey around the Sun, an entire human generation compressed into what Saturn experiences as a single passing year. A single day on Saturn lasts only about 10.5 hours. Despite its enormous size, Saturn spins remarkably quickly on its axis, completing a full rotation in roughly 10 hours and 30 minutes. This rapid spin causes the planet to bulge noticeably at its equator and flatten slightly at its poles, giving Saturn a visibly squashed, less perfectly round shape compared to smaller, slower spinning worlds like Earth. Saturn's rings are made almost entirely of ice, with only a small amount of rocky material mixed in. Countless individual particles, ranging from tiny grains to chunks larger than a house, orbit Saturn in a thin, flattened disk, and the vast majority of that material is water ice, reflecting sunlight brightly enough to make the rings one of the most visually striking features anywhere in the solar system. Saturn's rings are extraordinarily wide, yet remarkably thin. Stretching outward from the planet, the full ring system can span a distance comparable to more than half the gap between Earth and the Moon, and yet in most places the rings are only about 10 meters thick, sometimes even less. Scaled down proportionally, Saturn's rings would be thinner than a sheet of paper laid across a football field. No one is entirely certain how Saturn's rings first formed. Several competing theories exist, including the possibility that the rings are the shattered remains of a moon or comet that wandered too close to the planet and was torn apart by gravity, or that they represent leftover material from the same era that formed Saturn and its moons. Each idea has supporting evidence, and the true origin of the rings remains an open, actively researched question. Saturn's rings may be far younger than the planet itself. While Saturn formed billions of years ago alongside the rest of the solar system, some research suggests the rings themselves could be considerably younger, possibly forming within only the last few hundred million years, meaning dinosaurs walking on Earth may have looked up at a Saturn with a very different appearance than the one we see today. The rings are divided into several distinct sections, separated by gaps of nearly empty space. Named largely with letters in the order they were discovered rather than their position outward from the planet, sections such as the A, B, and C rings are separated by visible gaps, including the wide, well-known Cassini division, a band of relatively empty space carved out partly by the gravitational influence of nearby moons. Tiny moons embedded within the rings help shape and maintain their delicate structure. Small moons, sometimes called shepherd moons, orbit within or near the rings, using their gravity to help keep ring particles confined into narrow, well-defined bands rather than spreading out and dispersing more broadly. Without these small gravitational shepherds, Saturn's rings would likely appear far less sharply defined than they do today. Saturn's rings may not last forever, and are actually being slowly pulled into the planet. Charged ice particles from the rings are gradually drawn inward by Saturn's magnetic field and gravity, raining down into the planet's upper atmosphere in a process sometimes called ring rain. Based on the rate of this loss, some researchers estimate the rings could fully disappear within a few hundred million years, an almost unimaginably long stretch of time by human standards, yet strikingly brief on a planetary scale. Saturn has dozens of confirmed moons, with new ones still occasionally being discovered. As of recent counts, Saturn's moon total numbers well over 100 confirmed satellites, ranging from tiny objects only a few kilometers across to massive worlds larger than the planet Mercury. The exact total continues shifting slightly as astronomers refine detection methods and identify additional small, previously overlooked moons. Saturn's largest moon, Titan, is bigger than the planet Mercury. Titan stands out as one of the most fascinating moons in the entire solar system, not only for its impressive size but for its thick, hazy atmosphere, a rare feature among moons, which are typically far too small to hold onto a substantial atmosphere of their own the way Titan clearly does. Titan is the only moon in the solar system known to have a substantial atmosphere. Wrapped in a dense, orange-tinted haze composed largely of nitrogen, Titan's atmosphere is actually thicker than Earth's own, a genuinely unusual trait for any moon. This thick atmospheric blanket obscures the moon's surface from ordinary visible light, requiring specialized instruments to peer through the haze and study the landscape hidden underneath. Titan has lakes and rivers, but they are filled with liquid methane and ethane rather than water. Because temperatures on Titan's surface hover far below freezing, water exists there only as solid ice, rock-hard, and immovable. Instead, methane and ethane, gases on Earth, exist in liquid form on Titan's surface, filling lakes, carving river channels, and even producing occasional rainfall in a completely alien twist on a landscape that otherwise looks remarkably similar to certain regions of Earth. Titan may have a vast underground ocean of liquid water hidden beneath its icy crust. Despite its frozen, methane-soaked surface, evidence gathered by passing spacecraft suggests Titan likely harbors a large body of liquid water deep beneath its outer ice shell, kept in a liquid state by internal heat and pressure, raising intriguing questions among scientists about whether such a hidden ocean could possibly support some very simple form of life. Saturn's moon Enceladus shoots geysers of water vapor and ice out into space. Despite being a relatively small, icy moon, Enceladus has captured enormous scientific interest due to dramatic plumes erupting from cracks near its south pole, spraying material from a hidden subsurface ocean directly out into space, some of which eventually falls back down and contributes material to one of Saturn's fainter, outer rings. The material erupting from Enceladus actually helps supply one of Saturn's rings. Ice particles ejected from Enceladus's south polar geysers spread out into orbit around Saturn, forming and continuously replenishing the diffuse E-ring. In a very real sense, one small icy moon is quietly, continuously feeding material into the broader ring system surrounding the planet it orbits. Enceladus's hidden ocean has been found to contain the basic chemical ingredients associated with life as we understand it. Scientific instruments studying material ejected from Enceladus's geysers have detected organic molecules and other chemical signatures considered relevant building blocks for life, making this small, icy moon one of the more compelling locations in the solar system for future research focused specifically on the possibility of life beyond Earth. Saturn's moon Mimas closely resembles a certain famous fictional space station. Mimas features an enormous impact crater so large relative to the moon's overall size that it gives the entire object a strikingly recognizable appearance, one that many people, upon first seeing images of it, immediately compare to a well-known fictional space station from popular science fiction, an amusing, purely coincidental resemblance. Saturn's moon Iapetus has two dramatically different colored hemispheres. One side of Iapetus is notably dark, while the other remains considerably brighter, creating a striking two-toned appearance unlike almost anything else observed among Saturn's other moons. Scientists believe dark dust, possibly originating from another moon, gradually settles onto one leading hemisphere, absorbing sunlight and further darkening that half over long stretches of time. Saturn's magnetic field is considerably stronger than Earth's, despite the planet's mostly gaseous composition. Generated deep within Saturn's interior, likely through the movement of electrically conductive liquid metallic hydrogen, the planet's magnetic field is powerful enough to create dramatic auroras near its poles, similar in basic principle to Earth's northern lights, though shaped by conditions considerably more extreme than anything found on our own smaller, rockier planet. Saturn's auroras have been observed shifting in response to the planet's fast-moving atmosphere and internal magnetic activity. Much like Earth's auroras respond to solar activity, Saturn's polar light displays shift and change in response to a combination of solar-wind interactions and complex internal magnetic processes, creating a slowly, quietly shifting glow near each of the planet's poles that spacecraft have observed and studied in considerable detail. A massive, six-sided storm has churned steadily at Saturn's north pole for decades. Unlike the more typical circular storms found on other planets, Saturn's northern polar storm forms a strikingly geometric hexagonal shape, wide enough that multiple Earths could fit comfortably within its boundaries. This unusual, persistent hexagonal pattern remains one of the more visually striking and scientifically puzzling features found anywhere in the solar system. Scientists are still refining their understanding of exactly why Saturn's polar storm forms such a precise hexagonal shape. While laboratory experiments simulating rotating fluids have successfully reproduced similar hexagonal patterns under certain specific conditions, researchers continue studying exactly how Saturn's particular combination of wind speed, latitude, and atmospheric depth consistently produces and maintains such a remarkably stable geometric shape over so many decades of continuous observation. Saturn experiences the fastest winds found anywhere among the solar system's planets, aside from its immediate gas giant neighbors. High-altitude winds near Saturn's equator can reach speeds dramatically faster than even the strongest hurricane-force winds ever recorded on Earth, a powerful, near-constant atmospheric flow driven by the planet's rapid rotation and internal heat, sweeping steadily around the entire visible globe. Saturn radiates more heat into space than it actually receives from the Sun. Despite sitting far from the Sun's warming influence, Saturn generates a meaningful amount of internal heat of its own, likely produced in part by helium slowly sinking deeper into the planet's interior and releasing gravitational energy in the process, a subtle, ongoing internal process contributing warmth from within the planet itself. Saturn's interior likely contains a small, dense core made of rock and metal, hidden deep beneath thousands of kilometers of gas. Although the vast majority of Saturn consists of hydrogen and helium, current models suggest a relatively compact solid or semi-solid core exists near the planet center, buried beneath extreme pressure and temperature conditions that would be genuinely difficult to fully replicate or directly study using instruments here on Earth. Deep within Saturn, immense pressure may compress hydrogen into an unusual metallic liquid form. Under the crushing pressures found deep inside gas giants like Saturn, ordinary hydrogen gas is believed to transition into a strange, electrically conductive liquid metallic state, a form of matter almost never encountered under conditions found naturally here on Earth, and one considered essential to generating the planet's unusually strong magnetic field. Saturn was known to ancient astronomers long before telescopes existed. Because Saturn is visible to the naked eye as a bright, steady point of light in the night sky, ancient civilizations including the Babylonians, Greeks, and Romans observed and tracked its slow movement across the sky for thousands of years, long before anyone possessed the technology needed to see its now famous rings directly. Galileo Galilei was the first person known to observe Saturn through a telescope, though he could not fully understand what he was seeing. When Galileo first turned his relatively primitive telescope towards Saturn in the early 17th century, the rings appeared blurry and indistinct, leading him to describe the planet as having strange handles or ears on either side, since the technology of his era simply was not powerful enough to reveal the true, separate ring structure clearly. It took several decades after Galileo's first observations for astronomers to correctly identify Saturn's rings as a distinct structure. Using a significantly improved telescope, astronomer Christian Huygens was able to observe Saturn with considerably greater clarity than Galileo had decades earlier, finally identifying the strange appendages as a distinct, flat ring surrounding the planet, resolving a mystery that had puzzled astronomers since Galileo's earliest observations. Saturn's rings occasionally appear to vanish entirely when viewed from Earth. Because Saturn's rings are extremely thin and tilted at an angle relative to Earth's line of sight, there are certain points during Saturn's long orbit when the rings appear edge-on from our perspective, becoming nearly invisible even through a telescope, a striking, temporary illusion caused entirely by simple orbital geometry rather than any actual physical change to the rings themselves. Saturn has been visited by several robotic spacecraft over the past several decades. Missions including Pioneer 11, Voyager 1, Voyager 2, and later the considerably more detailed Cassini mission have each traveled to Saturn, capturing increasingly detailed images and scientific data about the planet, its rings, and its many moons, gradually transforming Saturn from a distant, blurry telescope image into a richly detailed, well-studied world. The Cassini spacecraft spent 13 years directly orbiting Saturn, gathering an extraordinary wealth of scientific data. Launched in 1997 and arriving at Saturn in 2004, the Cassini mission spent over a decade closely studying the planet, its rings, and its many moons, dramatically reshaping scientific understanding of the entire Saturn system before intentionally plunging into the planet's atmosphere in 2017 to avoid any risk of contaminating potentially habitable moons nearby. Cassini's final act involved deliberately diving directly into Saturn's atmosphere. Rather than leaving the spacecraft adrift indefinitely after its mission concluded, engineers directed Cassini on a final controlled descent directly into Saturn's thick atmosphere, gathering valuable scientific data during its final moments before ultimately burning up completely, a deliberate, carefully planned ending designed specifically to protect nearby moons like Enceladus and Titan from any possible contamination. The Huygens probe, carried aboard Cassini, successfully landed on Titan's surface. In a genuinely remarkable technical achievement, the Huygens probe separated from the Cassini spacecraft and descended through Titan's thick atmosphere, eventually landing softly on the moon's surface and transmitting images and data back to Earth, marking the most distant successful landing achieved by any spacecraft up to that particular point in space exploration history. Images captured by Huygens revealed a landscape on Titan strikingly similar to certain river-carved regions found on Earth. Despite the extreme cold and completely different chemical composition involved, Titan's surface, shaped by flowing liquid methane rather than water, displayed drainage channels, smooth stones, and other features remarkably reminiscent of familiar riverbeds and shorelines found here on our own considerably warmer planet. Saturn's atmosphere contains storms considerably larger than any storm ever recorded on Earth. Occasionally, an enormous storm system known as the Great White Spot appears within Saturn's atmosphere roughly once every Saturnian year, growing large enough to wrap entirely around the planet's circumference, a dramatic, periodic atmospheric event considerably larger and longer-lasting than any storm system Earth's atmosphere has ever produced. Saturn's distinctive pale gold coloring comes primarily from ammonia crystals present in its upper atmosphere. Clouds composed largely of ammonia ice give Saturn's visible surface its characteristic soft, pale yellow-gold appearance, a considerably more muted, gentle coloring compared to the more dramatic, swirling bands typically associated with its larger, more colorful planetary neighbor, Jupiter. Saturn's overall atmosphere is considerably calmer and more muted in appearance compared to Jupiter's, despite both being large gas giants. While Jupiter's atmosphere displays bold, sharply defined colorful bands and storms, Saturn's atmosphere generally appears softer, hazier, and less visually dramatic from a distance, largely due to a higher altitude haze layer that tends to soften and blend the underlying atmospheric bands and storm systems beneath it. Saturn's overall composition is remarkably similar to that of the Sun itself, dominated by hydrogen and helium. Because Saturn formed from much of the same original material that formed the Sun and the rest of the solar system, its overall chemical makeup closely mirrors that of our own star, differing mainly in scale, temperature, and the fact that Saturn never accumulated quite enough mass to ignite nuclear fusion the way the Sun eventually did. Saturn is sometimes described as a failed star, though this description requires some scientific nuance. Despite sharing a broadly similar composition with the Sun, Saturn possesses nowhere near the mass required to trigger the nuclear fusion process that powers true stars, meaning it would require dramatically more mass, far more than simply a larger version of Saturn, to ever have any realistic chance of becoming an actual star itself. Saturn's moon Rhea may have a faint ring system of its own, according to some scientific evidence. Data gathered by the Cassini spacecraft suggested the possibility of a thin debris disk surrounding Rhea, Saturn's second largest moon, which, if ultimately confirmed, would represent the first ring system ever discovered around a moon rather than a planet, an intriguing possibility that continues to be studied and debated among planetary scientists. Saturn's moonpan resembles a small, flattened dumpling shape due to material collected from a nearby ring. Orbiting directly within one of the narrow gaps found in Saturn's ring system, the small moonpan has gradually accumulated ring material around its equator through gravitational attraction, forming a distinctive raised ridge that gives the tiny moon an unusual, distinctly non-spherical appearance quite unlike most other moons found throughout the solar system. Saturn's rings produce a faint, barely visible shadow cast directly onto the planet's cloud tops. Because sunlight streaming through the ring system is partially blocked by ring particles, a faint shadow line is cast onto Saturn's upper atmosphere below, shifting gradually in width and position over the course of the planet's long, nearly 30-year orbit around the Sun, a slow, quietly shifting reminder of the ring's enormous physical scale. Saturn's seasons last many years, considerably longer than seasons experienced anywhere on Earth. Because Saturn takes nearly 3 decades to complete a single orbit around the Sun, each of its 4 seasons stretches out across roughly 7 Earth years, meaning a single Saturnian summer or winter can last longer than an entire childhood spent growing up here on Earth. Saturn's axial tilt is fairly similar to Earth's, which is part of why it experiences seasons in the first place. With an axial tilt of roughly 27 degrees, reasonably close to Earth's own axial tilt of approximately 23 degrees, Saturn experiences a broadly similar seasonal cycle to our own planet, differing mainly in scale and duration due to its considerably longer overall orbital period around the distant Sun. Saturn's moon Titan has weather patterns, including clouds, rain, and wind, despite its extreme distance from the Sun. Because Titan possesses a substantial atmosphere and a stable liquid cycle involving methane rather than water, it experiences genuine weather phenomena, including seasonal cloud formation and occasional rainfall, making it one of the very few places in the solar system, beyond Earth itself, known to feature an active, ongoing weather cycle. Some scientists have speculated about Titan's methane lakes potentially supporting an entirely different, currently unknown form of chemistry-based life. Because Titan's environment is so radically different from Earth's, some researchers have proposed the theoretical possibility of life based on entirely different chemistry, potentially using liquid methane rather than water as a solvent, an intriguing, highly speculative idea that remains firmly within the realm of ongoing scientific curiosity rather than confirmed discovery. Saturn's rings reflect sunlight so effectively that they significantly increase the planet's overall brightness as seen from Earth. Because the icy particles making up the rings reflect a considerable amount of incoming sunlight, Saturn appears noticeably brighter in Earth's night sky than it otherwise would based on the planet's cloud-top brightness alone, an optical boost provided directly by the enormous, ice-covered ring system surrounding it. Saturn's moon Hyperion tumbles chaotically through space rather than rotating in a smooth, predictable pattern. Unlike most moons, which settle into a stable, predictable rotation pattern over time, Hyperion's irregular shape and the gravitational influence of nearby Titan cause it to tumble somewhat unpredictably as it orbits Saturn, making its future orientation at any given moment genuinely difficult for astronomers to precisely calculate in advance. Saturn's moon Phoebe orbits the planet in the opposite direction compared to most of Saturn's other moons. While the majority of Saturn's moons orbit in the same general direction as the planet's own rotation, Phoebe travels in a retrograde, or reversed, orbital direction, along with an unusually distant and tilted orbital path, leading scientists to believe it may have originally formed elsewhere entirely before eventually being captured by Saturn's gravity. Saturn's gravitational influence helps shape the overall structure of the asteroid belt located much closer to the Sun. Even from a considerable distance, Saturn's substantial gravitational pull interacts with Jupiter's own gravity to influence certain gaps and structural patterns found within the asteroid belt, illustrating how the gravitational influence of the solar system's largest planets extends considerably further than their immediate visible surroundings might initially suggest. Saturn's moons display an extraordinarily wide range of sizes, shapes, and surface characteristics. From tiny, irregularly shaped moonlets only a few kilometers wide to massive, atmosphere-bearing worlds like Titan, Saturn's collection of moons represents one of the most genuinely diverse assortments of natural satellites found anywhere in the solar system, each one offering scientists a distinct, individually fascinating small world to study in detail. Saturn's ring system can be seen clearly even through a relatively modest, affordable backyard telescope. Unlike many other remarkable astronomical features that require professional-grade equipment to observe clearly, Saturn's rings are bright and distinct enough to be genuinely visible, weather and viewing conditions permitting, through even a modest amateur telescope, making it one of the most consistently rewarding and popular targets for casual stargazers throughout history. Saturn appears as a small, pale golden dot to the unaided human eye, without any hint of its rings visible at all. Without any telescope or other optical aid, Saturn simply looks like an unusually steady, moderately bright star to the naked eye, giving no obvious visual indication of the vast, intricate ring system and diverse collection of moons quietly surrounding it, an entire elaborate planetary system hidden behind what appears to be a single simple point of light. Saturn's overall mass is roughly 95 times greater than that of Earth, despite its comparatively lower density. Although Saturn is considerably less dense than Earth, its sheer physical size more than compensates in terms of overall mass, resulting in a planet with dramatically more total material than our own, an enormous quantity of mostly gaseous material held together by the planet's own substantial internal gravity. Saturn's gravity at its visible cloud-top level is actually quite similar to Earth's surface gravity, despite the planet's much larger overall size. Because Saturn's lower density partially offsets its much greater size, the gravitational pull experienced at the level of its visible clouds ends up being fairly comparable to gravity experienced here on Earth's own surface, a somewhat counterintuitive fact given the truly enormous overall scale difference between the two planets. Saturn's rings are officially named in a somewhat unusual, historically inconsistent order. Because the rings were named roughly in the order they were discovered rather than according to their actual physical position relative to the planet, the resulting naming system can feel a little confusing at first glance, with the widely recognized A, B, and C rings not necessarily appearing in a simple, straightforward outward sequence from Saturn itself. Saturn's largest ring gap, known as the Cassini division, is wide enough to fit several Earth-sized planets side by side. Spanning a considerable physical distance, the Cassini division represents one of the most visually striking and easily recognizable features within Saturn's ring system when viewed through even a moderately capable telescope, a wide, dark gap created in large part by the ongoing gravitational influence of Saturn's moon Mimas. Saturn's moon Titan takes almost 16 Earth days to complete a single orbit around the planet. Compared to many of Saturn's smaller, faster orbiting moons, Titan follows a considerably slower, more leisurely orbital path around its parent planet, gradually circling Saturn roughly once every 16 days, a stately, unhurried rhythm quite different from the much faster orbital periods observed among some of Saturn's smaller, closer moons. Saturn's icy moon Enceladus reflects nearly all of the sunlight that reaches it, making it one of the brightest objects in the entire solar system. Because its surface is covered almost entirely in fresh, clean ice, continuously replenished by ongoing geological activity, Enceladus reflects an extraordinarily high percentage of incoming sunlight, giving it one of the brightest, most reflective surfaces of any known object anywhere within our solar system. Saturn's overall system, including its rings and many moons, is sometimes informally described by scientists as resembling a miniature solar system of its own. With a large central body, a wide variety of orbiting moons of dramatically different sizes, and even ring material reminiscent of a much smaller, flattened debris disk, Saturn's overall system bears a loose structural resemblance to a miniature version of our broader solar system, an elegant, smaller echo of the same basic gravitational patterns playing out on a considerably reduced scale. Saturn will likely remain visible in roughly the same region of Earth's night sky for many years at a time, due to its slow orbital movement. Because Saturn takes nearly 3 decades to complete a single orbit around the Sun, it appears to move only very gradually against the backdrop of distant stars from our perspective here on Earth, remaining recognizable in roughly the same general area of the night sky for extended periods lasting several consecutive years at a time. Saturn's moon Titan may eventually be considered one of the more promising locations within our solar system for future robotic exploration specifically focused on searching for signs of life. Due to its complex atmosphere, active liquid cycle, and potential subsurface ocean, Titan remains one of the more scientifically compelling targets for future dedicated missions, with several concepts, including drone-like flying vehicles designed specifically to explore its unique atmosphere and surface, currently under ongoing scientific consideration and development. Saturn's overall system continues to be studied through data collected by the Cassini mission long after the spacecraft itself was intentionally destroyed. Because Cassini gathered such an enormous volume of scientific data across its 13 years directly orbiting Saturn, researchers continue analyzing and publishing new findings drawn from this rich archive even now, meaning our collective scientific understanding of Saturn keeps quietly expanding long after the spacecraft that gathered the data has already ceased to exist. Saturn's rings can cast a faint reflected light onto the planet's night side, dimly illuminating clouds that would otherwise sit in complete darkness. Much as moonlight softly illuminates the nighttime landscape here on Earth, sunlight reflecting off Saturn's icy ring particles can cast a faint secondary glow onto portions of the planet's unlit side, a quiet, borrowed light bouncing gently down from the rings above. Saturn's moon Dione has wispy, bright streaks visible across parts of its surface, later identified as long, delicate ice cliffs. Early images of Dione revealed strange, pale streaking patterns that puzzled scientists for years, until closer observation eventually revealed the streaks to be networks of long, bright ice cliffs, formed through geological fracturing, catching, and reflecting sunlight in a way that had initially resembled a much less structured, more mysterious surface pattern. Saturn's moon Tessis features an enormous canyon system stretching most of the way around the moon's circumference. Known as Ithaca Chasma, this massive canyon system stretches across a considerable portion of Tessis, likely formed either through internal geological processes or as a result of a powerful ancient impact, standing as one of the more dramatic and visually striking surface features found among Saturn's collection of smaller icy moons. Saturn's magnetic field is closely aligned with its rotational axis, unlike the magnetic fields of several other planets in the solar system. This close alignment makes Saturn's magnetic field unusually symmetrical and well-behaved compared to some other planets, whose magnetic fields can be noticeably tilted relative to their rotation, a subtle but scientifically significant detail that has made Saturn a particularly useful subject for studying planetary magnetism more generally. Saturn's rings are thought to be composed of debris ranging in size from tiny dust grains to boulders larger than a house, all orbiting together in a shared, flattened plane. This enormous range in particle size means the rings are not a uniform, simple structure, but rather an intricate, layered collection of countless individual objects, each following its own slightly distinct orbital path while remaining part of the same overall visible structure. Saturn's atmosphere features distinct cloud bands, though they tend to be considerably less visually dramatic than the bold, contrasting bands found on Jupiter. A high-altitude haze layer sitting above Saturn's main cloud decks tends to soften and blend the boundaries between individual bands, giving the planet its characteristically gentle, muted overall appearance compared to the sharper, more strikingly colorful cloud patterns typically associated with Jupiter. Saturn's moon Janus and its neighboring moon Epimetheus share a genuinely unusual orbital relationship, periodically swapping orbits with one another. Roughly every 4 years, these two small moons approach closely enough that their mutual gravity causes them to gently exchange orbital positions, with the inner moon shifting slightly outward and the outer moon shifting slightly inward, a delicate, repeating gravitational dance unlike almost any other relationship found among the solar system's many moons. Saturn's distance from the Sun means sunlight reaching the planet is considerably fainter than sunlight reaching Earth. Because Saturn orbits roughly 9.5 times farther from the Sun than Earth does, the sunlight illuminating its rings and cloud tops is dramatically weaker than the sunlight we experience here, meaning Saturn spends its entire existence bathed in a comparatively dim, distant version of the same daylight familiar to us. Saturn's core, despite being relatively small compared to the planet's overall size, is believed to be considerably hotter than the planet's outer atmosphere. Deep within Saturn, extreme pressure generates significant heat, with core temperatures believed to reach many thousands of degrees, a striking contrast to the frigid, icy conditions found within the rings and among many of the planet's outer moons drifting through the cold surrounding space. Saturn's rings were first suspected, though not confirmed, to be made of countless individual particles rather than a single solid structure, based on careful mathematical analysis conducted well over a century ago. Long before any spacecraft ever visited Saturn directly, mathematical calculations demonstrated that a solid ring simply could not remain gravitationally stable, strongly suggesting instead that the rings must consist of many separate, individually orbiting particles, a theoretical prediction later directly confirmed by spacecraft observations. Saturn's moon Titan experiences a very slow, gradual seasonal cycle of its own, mirroring Saturn's broader seasonal pattern around the Sun. Because Titan orbits Saturn while Saturn itself slowly orbits the Sun, Titan experiences its own long, gradual seasons lasting roughly 7 Earth years each, with corresponding shifts in cloud patterns and surface lake levels documented by spacecraft observing the Moon across different points in this extended seasonal cycle. Saturn's rings appear to shine with a subtle range of colors when studied closely through specialized instruments, rather than appearing as a uniform, single shade. Variations in ice purity, particle size, and the presence of small amounts of rocky or dusty material across different sections of the ring system produce subtle color variations detectable through careful spectroscopic analysis, even though the rings generally appear pale and mostly uniform to the unaided human eye. Saturn's moon Mimas, despite its heavily cratered appearance, is believed to harbor a slightly unusual internal structure based on subtle wobbles detected in its rotation. Careful analysis of small irregularities in how Mimas rotates has led some researchers to propose the Moon may contain either an unusually shaped rocky core or possibly even a small hidden ocean, an intriguing possibility that continues to be studied and debated using data gathered from earlier spacecraft observations. Saturn's larger storms can produce visible lightning, detected remotely by passing spacecraft instruments. Similar in basic principle to thunderstorms here on Earth, though occurring on a considerably larger scale, storms within Saturn's turbulent atmosphere have been shown to generate lightning, detected through radio emissions and occasionally faint visual flashes captured by spacecraft cameras observing the planet's night side. Saturn's overall system contains such a wide variety of moons that scientists often group them into broader categories based on size, composition, and orbital characteristics. Rather than treating every one of Saturn's many moons as an entirely unique case, researchers frequently organize them into general categories, distinguishing between larger, spherical moons, smaller irregular moonlets, and tiny ring-embedded shepherd moons, helping make sense of such a remarkably large and varied overall population. Saturn's moon Titan is one of only a small handful of objects in the solar system, beyond Earth, where spacecraft have successfully landed directly on the surface. Alongside the Moon, Mars, and Venus, Titan holds the distinction of having been the site of a successful spacecraft landing, when the Huygens probe touched down in 2005, transmitting valuable surface data and images back to Earth from an astonishing distance. Saturn's overall brightness in Earth's night sky varies somewhat depending on both the planet's distance from Earth at any given time and the current angle of its rings relative to our line of sight. Because both Earth's and Saturn's positions constantly shift along their respective orbits, and because the visible tilt of Saturn's rings changes gradually over the course of decades, the planet's exact brightness as viewed from Earth fluctuates somewhat depending on precisely when it happens to be observed. Saturn's moon Enceladus is now considered one of the more promising locations within the solar system for potentially finding conditions suitable to microbial life, based on data gathered from its icy plumes. Because its subsurface ocean appears to contain liquid water, organic molecules, and a source of internal heat, all generally considered important ingredients for life as we understand it, Enceladus continues to attract considerable scientific interest as a genuinely compelling target for future dedicated exploration missions. Saturn's ring system, despite its enormous width, contains remarkably little total mass compared to the planet itself. Although the rings stretch across an enormous physical distance, the combined mass of all the ice and rock particles within them is estimated to be quite small relative to Saturn's own overall mass, illustrating just how thin and comparatively lightweight this visually dominant, instantly recognizable feature actually is. Saturn's slow, stately orbit means its position among the background stars barely shifts from one year to the next, from Earth's perspective. Someone observing Saturn casually from year to year might notice only a very slight, gradual shift in its position relative to the surrounding constellations, a visible reminder of just how slowly this distant, ringed giant makes its way around its very long, nearly 30-year orbital path. As our journey through Saturn and its quiet, golden rings comes to a close, perhaps the night sky feels a little wider now. Not just a scattering of distant lights, but an entire slow, ringed world turning patiently in the cold dark, wrapped in ice, circled by more than 100 moons, home to hidden oceans, methane rain, and a storm shaped like a perfect hexagon that has churned steadily for longer than most of us have been alive. We've drifted past rings thinner than paper stretched wide enough to hold a moon, past a small icy world quietly feeding material into space, past a spacecraft's final, deliberate plunge into gold-tinted clouds. Somewhere out there, far beyond the reach of an ordinary evening sky, Saturn continues turning slowly, exactly as it has for billions of years, entirely unaware that anyone down here is drifting off to sleep while thinking about it. Now you can let all of that drift softly into the background. Let your breathing slow. Let your shoulders loosen. Let the images fade from bright detail into something softer and more distant, like faint ring lights scattering gently across a quiet, darkened sky. And if you enjoyed this journey, perhaps you might like, subscribe, or share a thought below. It helps other curious minds find their way here. 2. One quiet orbit at a time. And if you happen to still be awake, there will be another slow journey waiting for you on the screen, another distant world to drift into gently. But for now, let your mind grow still, and let the day fall away. Sleep well, and good night.